Slope and product rule. Given f of x equals x over x plus 2, which point or points xy on the graph of fx have the property that the line tangent to f of x at xy has a slope of 1/2? Okay. So slope, as soon as you see slope, you think derivative. So f prime of x equals dy dx. True, yes, okay. So I'm going to rewrite this as y equals x over x plus 2, but now I need to find dy dx from this. And f of x and y are the same. I just feel more comfortable with dy dx, or with y. So I'm going to rewrite this one more time. I know, so many rewrites. X plus 2 to the negative 1. And I do the negative 1 part just because it lets me do the product rule. If I left the x plus 2 on the bottom, I would have to do the quotient rule, which is fine. But I prefer just to do the product rule because it's one fewer formula that I have to memorize in life. And it hasn't really, I haven't got my comeuppance yet, so I keep doing it. All right, so in this case, u would equal x, v would equal x plus 2 to the negative 1. V prime would be, and this, we're going to have to do the chain rule here, so negative 1 x plus 2 to the negative 2 times 1, which is the derivative of the interior. So this will be negative 1 over x plus 2 quantity squared. And it's just the bottom squared, not the top and the bottom. Because you square the top, then you get positive 1. And then that 1 just, it's fine. And then u prime equals 1. And then we're left with, what are we left with? uv prime equals uv prime. So it'd be negative x over x plus 2 squared plus u prime, which is 1 over x plus 2. Okay? And I'm going to try and simplify this a little bit. I'm going to multiply the right side here by x plus 2 over x plus 2. I don't have to do this, but since I'm using it, it might be easier to have it all combined. So we'll have negative x plus 2 all over x plus 2 quantity squared, which is, these cancel, which equals 2 over x plus 2 squared. Okay, so now we have our dy dx. Copy this. I'm so lazy. That's how lazy I am. So lazy. Don't even rewrite dy dx. Okay, so now we have this guy, got that guy. What are we supposed to do? 1/2? Slope of 1/2? Okay. So we're supposed to find points where we have 1/2. So we know that 2 over x plus 2 squared equals 1/2. So we might be able to just find this in terms of x, and then, so we just worry about the left term here, and we make sure the y matches up later. Maybe. Let's go for that. So we have 4 multiplied by 2 equals x plus 2 squared. Square root both sides. We have 2 equals x plus 2. But then we also, no, that's good. Yep. 2 equals x plus 2. Yep, I'm good with that. And so x equals 0. I feel like I missed something there. So x equals 0 is a possibility, but I'm not sure why this negative 4 is here. Ah, this is why. Okay. So when I did that square root, I should have been more careful. So this could also be negative 4. So, okay. How does that work? So then, if we plug in negative 4 here, so we know that 4 equals negative 4 plus 2 quantity squared. So to solve that, when I square rooted both sides, I should also say that -2 equals x plus 2. And therefore, x can equal -4. So key point for life, when you take the square root to get rid of your square, you also have to do the negative side as well. So x plus 2 equals -2, or x plus 2 equals 2. And we get the two values, x equals 0, x equals -4. And so it's going to be one of these two, I think. And now we need to find out what -4 actually equals when we plug it in there. So if we do f of -4, that equals, I should clean this up. So messy. Very true. Click. Click. There we go. Perfect. Ideal. Therefore, f of -4 equals -4 over -4 plus 2, which equals -4 over -2, which equals 2. Okay, so it does not equal 2/3. That point does not exist. And so we're left with, I can do a better job. Right there, right there. Excellent. So we have the points 0, 0, or -4, 2 as two values, or two sets of points, two sets of pairs, two xy points where the slope would be 1/2. So to recap real quick, we're given f of x. We're saying, hey, we want the slope of 1/2. It's like, okay, so we'll take the derivative of f of x, give us f prime of x. We set f prime of x equal to 1/2. We solve for the x value, making sure to be careful of that square root. And we found two possible x values, 0 and -4. We then use those x values to then find the potential y values, which turned out in this case was 2. Excellent.